So, Advanced Multipurpose Infrastructure, self-managed cloud environment with HashiCorp Terraform. What was it, how it was done, why do we need it, and what we reached? Let me start from introducing myself, but just a couple of words. I'm a developer advocate at DataStax Incorporated. I work with distributed databases for last months, but beforehand I was a software architect, a technical lead, and of course, DevOps evangelist. So that's all together allowed me to change a lot in my former teams and bring some very nice changes, I believe, to make the things work well and done fast. First phase, I want to discuss problems and following solutions. Before discussing any system, any application, any automation done by you, you have to clearly describe what's the problem you are solving. Because if you can describe the problem, I doubt if a solution will work well. What was our problems when we started, what we started to solve? First one is the changes management. That's all about changes management. Infrastructure works well, more or less usually, as long as you don't touch it. As long as you start to add new machines, as long as you start to change something, make new routes, create new firewalls, change everything you may change in your infrastructure, that all may go pretty bad. And in the most of the cases, in most of the companies I've seen, as the change was done, just 1 week later, no one was able to say why it was done. What was the reason when, for what exactly it was done, and who did it, whom to ask. Change management is a pretty complicated thing. We will address, actually, many thanks to HashiCorp for addressing this issue. We will discuss it as a solution a few steps later. Second problem. Guys, I don't know how about you, I'm very lazy. I hate to do the same job again and again and again. And as I was leading DevOps team in a pretty intensive project with few teams working together, it every day was a lot of people reaching us, guys, please create a new instance, guys, please discard previous instance, we need few more, and that's more or less fine, as you need no custom setup, but that custom setup needs to be done pretty often. For example, one day my boss reached me with a request. We need 2 instances. One instance should be like exactly the new one, right from master branch, our latest release. That's perfect. And second one, I need an instance which will show exact state of our application 1 year ago, because I want to show to our investors the things we reached in last year. And so on and so forth. Quality assurance need instances for manual tests. Automated tests also need some firepower, and so on and so forth. And also we have to apply some changes for the production. And if you do such a lot of changes manually, by going to AWS or OpenStack or whatever cloud you use, that's going to make you very tired, and that's not the way to keep work transparent and understandable. Last thing, cost efficiency. We were pretty above our budget, because as we start to use some for production, for example, it runs and runs and runs, even if we don't need the server right now. For example, our company were operating mostly for Europe, so There are 2 free time zones we have to cover, and if we have night, no one uses our machines. So we want to decrease firepower during the night. But we always, of course, want to have some servers and power reachable for our clients to provide always uptime solution for them. No doubts. So that's the 3 main problem we reached, we got. And now I want to say something about the solutions we use it to address them. First one, well, that was already pretty obvious, cloud computing. We dropped bare metal for pretty long time, and we adopted cloud very early. In the beginning, it was AWS, but after some calculations, we decided to switch to hosted OpenStack, and we use it OVH. Maybe those of you who are from Europe know it. I can say from my experience, for us, it worked very well. So I'm satisfied with our OpenStack experience and with our OVH experience. For those who knows OpenStack, that's good to go. For those who doesn't know, I must say what OpenStack is, let's say, your own self-hosted cloud, but we weren't hosting it on our own. We were using a hosted solution. So that's basically a cloud like an AWS or a Google Compute Cloud, just a bit different. There is no principal difference so far, I would say. At least at this level, we don't get too deep so far. Second, infrastructure as a code. Thanks HashiCorp for the Terraform. These tools significantly improved our experience working with our infrastructure. Beforehand, we had just a cloud, and every DevOps team member was able to go there, change any settings, and like submit that, spawn a new node. But it wasn't, as the first problem I've mentioned it. It was still manual control, and it was not transparent and not traceable. If, let's say, this server has, I don't know, usually these servers like that have 16 gigabytes of RAM, and this one have exactly 8. Why? Who changed the setting? Why it was done? As long as we introduced a Terraform, all the changes were done with Terraform configuration files. I guys believe I don't have to explain what the Terraform is, because that's like more intermediate level talk, and I believe you know what the Terraform is. Speaking very, very briefly, if we have some novice guests, Terraform is a tool which allows you to describe your infrastructure in configuration files. And when using these configuration files, Terraform makes proper API calls to your clouds to make their required changes. I believe that's enough as an explanation. And here comes the third part of the solution, version control. Altogether, we were using Git. Git and Terraform make really powerful things that altogether makes you using infrastructure as a code. And I believe that's the breakthrough. Now, every change was also submitted to a version control, and in commit message, everyone who was doing this change specified a Jira ticket number. So basically, whatever you do, you must specify ticket number, where in the Jira ticket comments, you write what was done, why it was done, who ordered these changes, and what was exact reason. And then using Git tools, you always may see what exactly was changed. So all the Git diff, Git log, Git blame, and so on, you see how, when, and what. And it was already great, but it was not enough. Originally, everyone was working with the same repo, but locally. So we were cloning this repo, bringing any changes, submitting them, pushing them, making Terraform apply. So far, so good, as I was working alone and DevOps transformation has just started in our former company. But after some time, we were working 5 of us. And that's not really nice if you have few Terraform applies running at once from different machines with different Terraform configuration file state. That was obviously a failure. So what we did, first part of this sub-solution was pretty simple. We moved all the credentials and all the access to one dedicated server. And from now on, all the changes we did, we were able to do only from this exact server. So if you try to run Terraform apply, but your colleague started something already, you will be blocked because one apply is going on. Better, but we can do more. Automation. Automation is one of my favorite words, tools, principles, so on and so forth. If you do the same job again and again, you probably do it wrong. And automation with proper tools give you great access to all the history you need and very centralized management of it. After some months, we moved all the Terraform related operations to Jenkins. And here, guys, come a little question. A lot of you, and I was like that before, will consider Jenkins as a simple build server. Nope. That's not just build server, that's something much more. That's the thing which allows you to do nearly everything. Especially as you use proper tools and plugins. We were using Groovy, and that's the thing what changed it really a lot for us. What's the Groovy by itself? Groovy, it's a language ready to work in Java virtual machine. So it's really close by syntax and by main principle, let's say, to Java, but it's not Java. First of all, it's interpreted. And second of all, you can use it directly with your Jenkins setup. So if you have Groovy enabled support in Jenkins, you can write all your automation using normal high-level tool, not the bash scripts, but the high-level programming language with support of exceptions, with support of some parallel calls, with support of very many cool features you use it to use in high-level programming languages. And two more things, as it's very close to Java by the syntax, it's really easy to read and really easy to support. As we started with this automation, no one had any Groovy knowledge in the beginning, and after a month maybe of work with it, as we had some Java experience, of course, it was really readable, clean, split to libraries, clean code. It was easy to use. And second of code, in this case, running Groovy with Jenkins, Groovy is completely integrated with Jenkins. So you may call some native Jenkins calls, you may switch from one job to another, iterate through jobs, call whatever jobs with any arguments you need. And all the things since that moment were done with Jenkins. So imagine if you want to add 2 more servers to a production, or if your colleague from quality assurance wants to have some more instances for different branches of different services. We were working on microservice architecture, so it wasn't so easy to deploy. We gave them tools to do it with Jenkins. If you want to add 2 more servers to a production, you simply go launch Jenkins job. Jenkins asks you for the exact amount of servers and their templates you want to use with it, and you launch it, and in a couple of minutes, your cluster is extended with these machines. And as you launched it, you basically have no reasons more to take care of it, because it will be done by Jenkins and following tools. Configuration management, I will not talk too much about it. I believe you guys know what the configuration management is. We were using Puppet. As long as your Terraform files are adjusted by Jenkins, in my case, and applied with Terraform apply, these things, these servers must be configured. And don't forget, though Terraform is a really amazing tool, it's not the configuration management tool. I've seen some guys trying to do configuration management with Terraform. Usually it doesn't look well for a very simple reason. That's not the main thing for the Terraform to do. It's an infrastructure management tool. So in our Terraform templates, we were using basically only very simple thing, just to install a Puppet agent and make them running, and then all the other configuration is done by Puppet. I will not talk on it so much. I hope it should be clear for you at this stage. And last thing, developer experience. Really, guys, stop the madness, give them tools. Before we implemented these automation, we had a lot of issues, like when some of the developers need some more servers in the cloud for their dev environment, for their staging, to test their pull requests, to check how it works all together, to run some integration tests, so on and so forth. And they were reaching us, please, we need some more machines. And we were really busy, as for example, we had some issues on production. Of course, there is no chance we will drop production to create some instances for our beloved developers. And they were waiting, we were blocking them. And it happened again and again and again. And that was one of the reasons to start the wall transformation. Give them tools. If they need this firepower, they need to have it now. Otherwise, you may block the whole, I don't know, backend team. In our case, it was pretty big team. So that wasn't a daily use case, but it happened again and again. What do I mean by give them tools? In our case, as all the job was already done by Jenkins, it was only a simple question to create simple jobs with very simple setup, where you should not specify a lot of different things. Like our Jenkins jobs for internal usage were pretty complicated. You may specify whatever you want, how exactly this thing is going to attach to Kubernetes. We were using Kubernetes later. What's the exact amount of CPU cores and so on. No. For developers, we didn't need that. So we simply created wrapper jobs, which were calling these lower level jobs with already given amount of, with some proper configuration. What has to be installed from which branch has to be installed application. That's usually all what I need. And that first about a manual launch, manual requests for the system, for the instances. When we speak about the automation of automation, we use it heavily merge requests. If you want to put your changes into the master branch of one of our services, you weren't allowed to do it just like this. You must do pull request. Using the infrastructure automation we created already, it was really easy to add one more step. If you create a merge request, it means what it has to be tested. So on the merge request, GitLab, we were using GitLab, calls again Jenkins. And then what happens? Jenkins reacts to this merge request, calculates the change set, and creates a test instance in the cloud for the quality assurance team and for automated tests, end-to-end tests, I mean, not a local one. That was pretty big application, so it needed some significant resources to run end-to-end tests on it. As long as these instances created, tests are launched by automatically. That's a separate Jenkins job. And as it's done, Quality assurance team receives a letter what they can do their job. As they write a comment to merge request like, okay, we agree, and merge request is merged, Jenkins again receives signal from GitLab about it, and it will destroy this instance automatically as merge request is merged or vice versa, decline it. Okay, so that's the first phase. And I want to discuss now exactly our solution with no theory, with very exact solutions was used. So in general, that's the story of OpenStack in our case, but it will work with nearly any cloud which is supported by Terraform. Terraform by itself, GitLab to store Terraform configuration and call Jenkins if we have any changes in some merge requests, as I've mentioned. Jenkins with Groovy support and all the Groovy scripts to do an automation job, and excited users who want to work with this solution. For the simple use cases, user launches a job in Jenkins specifying what he needs to have. And of course, not everyone is allowed to do so. In the initial state, it was allowed only for team leads, because, well, on the team level, that's really a good approach to solve. If you have, I don't know, team of 20 developers, I don't want to give such tools to every of them. I want it to be more or less controlled. And let's imagine we have a front-end developer who wants to have these front-end changes running with some changes done in another branch of backend. So we have one, we didn't have monorepo, big mistake from my point of view. And I'm a front-end developer, I want to test changes from my branch with some backend, and I want to make it externally, not in my laptop. I'm calling Jenkins and asking to give me a test instance with access for the whole team to it, because I want all my colleagues to be able to test it. I don't know who exactly will test my solution. Jenkins checks out code Terraform configuration from GitLab. And that's very important to understand. We were only one main job doing any changes. And of course, this job may be launched only in single instance. So you can't run it a few times in parallel, otherwise you will get problems very, very soon. As long as this thing cloned the code, it uses a template of a Terraform file appropriate for this job. So for the test level, for the test instance, regular level, we have a special template, medium-sized machine, no persistent volumes mounted, and so on and so forth, like pretty ephemeral one. So Jenkins converts this template to a real Terraform configuration file, fills it with proper values, gives it the name, makes Terraform apply, and pushes the changes to GitLab. And as a last step, he was calling, that's not shown in this architecture overview slide, sorry guys. As a last step, he calls our DNS management system to update changes. So this machine will be reachable not by the IP address. IP address is not a convenient tool to reach the machines, but to provide a real domain name. So it was like job ID, test instance, blah, 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 staging, blah, blah, blah.com. As Terraform apply is done, obviously, OpenStack receives API calls from Terraform and spawns a new machine, and then configuration management, Puppet in our case, provides all the configuration for it, including all the things that described in Terraform config and Terraform template. So for example, we want to have our system, our application deployed there in the proper states from proper branches. Those branches were meanwhile built by Jenkins, so that was a very high parallel. I can say what in the beginning, initially, this job to spawn a new instance and deploy our application there spent, well, that's hard to say now, but the proof of concept version was approximately maybe 20-25 minutes before you get your application running in the new instance for you to test or to demonstrate to a client, depending on which team you work. In the end, thanks to a parallel, it was, depending on the change set, it was like 4 or 5 minutes, sometimes 3 minutes, let's say. Yes. So we have 3 minutes left, I believe. And let's, a final phase. Final phrase, who was a client of this solution? It was used by management team to show it to our potential clients, by sales, and so on. It was used by dev team to try to launch to try to launch application in different configurations. If you can do it locally by any reason, it was doing all the time. Quality assurance team very often used this approach to run few instances at once because they can't do few tests of different branches at once in their laptops. It was used by continuous integration to to run integration and end-to-end tests for the application by Jenkins by itself. So Jenkins was using his automation too, and it was using to manage production, to run more instances or run less instances to destroy not required instances, therefore for production purposes.